Hi everyone. Welcome. Good evening. Tonight's lecture is the last of our spring Baumer lecture series. It features the work of architecture sections Howard E. LeFevre, Emerging Practitioner Fellow Georgina Baronian. It's my pleasure to introduce Georgina, though having spent much of the last 9 months walking the halls of Knowlton, many of you have had the pleasure of getting to know her already. Georgina is a graduate of Princeton University, and she's a licensed architect in the state of New York. Her design practice with Clovis Baronian, explores the interrelation of climate and aesthetics, and how assumptions of acceptable thermal comfort can be critiqued and reconsidered through a spatial, experiential, and aesthetic lens. Prior to establishing an independent practice, Georgina worked in Tokyo, Japan, for the offices of SANAA and Junya Ishigami, where she worked on various projects including new cultural venues, educational institutions, housing, and large-scale public art installations. Her work has been recognized by the LafargeHolcim Foundation for Sustainable Construction's New Generation Global Prize, an important prize in global sustainable practices, and the Howard Crosby Butler Traveling Fellowship. In conjunction with the lecture, Georgina's exhibition, Ambient Architecture, has also commenced in the Banvard Gallery, and I invite you all to join for the exhibition opening immediately after the talk. Her exhibition uses the framework of ambient to not only question topics like climate, temperature, and weather, but also to speak of more ambiguous qualities like a mood, a tone, or a feeling that often escapes disciplinary distinctions. I guess one could say that Georgina is making visible the invisible. Ambient Architecture showcases 7 projects by Clovis Baronian that, through an interplay of layered spaces, soft monoliths, gradients of conditioning, and aesthetics of environmental performance, try to reframe the conversation about sustainability and argue for a reconsideration of our assumed notions of comfort. Please please join me in welcoming Georgina Baronian.
Thank you so much for the very generous introduction. And as you rightly mentioned, the work that I'm currently pursuing in both my academic and professional practice considers both the interrelation of climate and aesthetics, and how the assumed notions of production of thermal comfort can be critiqued and reconsidered through a spatial, experiential, and aesthetic lens. And so today I'm going to speak briefly about the conceptual framework that underlies and guides my research and design practice, and then I'll share a few projects that illustrate how I'm approaching these topics through a couple of different avenues. And so much of my work is focused on rethinking a homogeneous interior comfort that today is not only expected and desired, but also codified. The contemporary practice of architecture is regulated by a complexity of social, political, and institutional processes that have been manifested in the formation of codes and standards that control the design and performance of buildings. These prescriptive building regulations specify detailed elements of design and construction assembly so as to provide for accepted cultural norms of safety, security, and hygiene. While intended to maximize certainty, minimize risk, and ensure the timely and profitable production of space, regulations of the last half century have taken on a pervasive and definitive role not only in the building and construction industry, but also in contemporary architectural design. This codification goes as far as to prescribe specific definitions of a desired comfort, be it temperature, humidity, or noise level. The image on the left, for example, demonstrates the resultant minimum allowable indoor temperature as stated in the International Building Code. These assumed comfort levels arose from studies conducted throughout the middle of the 20th century, including those by P.O. Fanger in the early 70s, a photograph from which you see here on the right, and from which stemmed our existing predicted mean vote method of determining thermal comfort. And I think it's just worth pointing out that in spite of the prominence of women in this photograph, Fanger's equation of thermal comfort, which again remains the basis of thermal modeling systems that we employ today, utilizes as one of its key variables the resting metabolic rate of a 40-year-old man weighing 154 pounds. So I think a lot of the work is really kind of questioning whose comfort are we actually designing for today. And so historically, coinciding with the codification of architectural practice, the course of the 20th century saw the progressive mechanization of architectural space. The modification of climate for the construction of comfort is arguably a fundamental basis of architecture, both modern and ancient alike. And the concurrent development of technological advancements and the ever-expanding bureaucratic and legislative institutions managing design and construction gave rise to the now pervasive homeostatic comfort system. And so this correlation between code and comfort is embedded in product specifications and the standardization of performance criteria of particular building elements. And this is done through organizations such as UL, ANSI, ASTM, for example. And so on the right, here you can see a test conducted by ASTM utilizing a rainmaker in the analysis of water penetration in a window assembly. And so the resultant approved assemblies thus become prescribed elements of day-to-day construction. And through this standardization, the dichotomic view of exterior environment and conditioned interior that it promotes, the environmental performance of architecture has been distilled into the airtight envelope and an all but invisible infrastructure, that of modern HVAC, which in daily life has been rendered all but obtuse to the user, save perhaps for the interface of a thermostat. So today, codified comfort emphasizes the automated, the homogeneous, and the predictable. And it's exemplified by initiatives such as Passive House, which kind of speak to this idea that the pursuit of an airtight architecture has the potential to lull us into a false sense of thermal security in an anthropocentric age that arguably demands our awareness. And so to this end, my work is very much interested in exploring this idea of spatializing the envelope in pursuit of dissolving this liminal boundary of environmental performance, as opposed to prescribing discrete performative objectives to individual layers of a consolidated assembly, which is exemplified here in this illustration of a typical wall section of wood frame construction, paired with kind of the atomized and itemized requirements from the IRC. So instead of this kind of atomization, can we consider how form and space can take on a greater role in the production of comfort? And so this spatialization of the envelope has been considered before in the pursuit of an environmentally conscious architecture. One prominent example being the Solar House proposal by O.M. Ungers in 1980, which was an evolution of his previous studies into nested space. And so with his Solar House proposal, Ungers leveraged the performance capacities of these spatial concepts with a house composed of 3 layers: a stone core to retain heat that contained the bedrooms and dining room, a glazed second layer that encompassed the majority of the remaining infrastructure of the house, so the kitchens, the bathrooms, and a third operable greenhouse layer that was adorned with an ivy-grown trellis. And so through this organization, Ungers sought to produce a monometic domesticity, where the utility and experience of the house would change over the course of days and seasons. This proposal questioned the necessity of a single homogeneous interior. However, in its reliance on the application of distinct material assemblies with specific performative roles, the house continues to operate as a thickened version of a rather normative sandwich. So rather than relying on an approach of discrete surfaces or membranes, a lot of my work is questioning what the formal, programmatic, and aesthetic ramifications might be if we were to consider a more gradated approach. And so through this lens, is it possible to reimagine comfort solutions that are intended to inform not only the climatic performance of the construction, but at the same time choreograph an alternative programmatic use of space that is in concert with a variable exterior and that reacquaints the occupant with the system. And so whilst the latter concept has been explored by the likes of Rainer Banham and his A Home's Not a House proposal, which leveraged the pervasive mechanism for climate production as an active participant in the production of space, the pursuit here remains the creation of a homogeneous interior environment. One could alternatively look at the model of these ice fishers that you see here on the right, who are ice fishers in Kazakhstan that deploy discarded rice bags, ostensibly not to create a comfortable working environment, but rather to make a slightly less uncomfortable one. So in contrast to the dichotomic relationship that Banham sets up between interior and exterior climates, the ice fishers acknowledge their surrounding conditions and use what one could posit are ambient methods to mediate their surroundings and inadvertently kind of display their own aesthetic of climatization. And so really to think about this framework of ambient elicits, as Fu rightly mentioned, not only questions of climate, temperature, and weather, all fundamental concerns of the discipline, but also speaks to the idea of something more ambiguous, a mood, a tone, or a feeling. And so, referencing the work of media theorist Paul Roquet, this pursuit of ambience is intentionally privileged over concepts of atmosphere. While atmosphere presents a more objective condition of the surrounding environment, ambient, as described by Roquet, implies a mediation of these prevailing conditions by the human senses. This notion of ambient speaks to an architectural condition where an individual undergoes a process of attunement, achieving some sense of fleeting harmony or resonance with one's environment. Fleeting in the fact that ambient environments are ever-changing and demand a continuous process of attunement. So, what are the qualities of an ambient architecture? How does it operate? And what does it look like? In my practice and in my research, I've begun to work through these questions within a variety of programs, scales, and contexts. And within these projects, conceptual through lines have begun to emerge, which may in turn begin to describe the qualities of an ambient architecture. Layered space, soft monoliths, gradients of conditioning, and aesthetics of environmental performance. So with my work, I'm really tackling this idea of ambient architecture from two sides. On the one hand, opportunities to reconsider conditioning through the production of layered space within a domestic setting has been investigated in traditional building projects. However, to a degree, perhaps, these projects currently share what might be seen as the critical limitations of the solar house model, that being the construction of layers of distinct membranes with discrete functions and resultant zones between them. Meanwhile, through my research and installation projects, the aesthetic and performative are distilled into a single operation, generating a new interior through a single material surface. This is to say, moving from the conception of spatial layers to the creation of a gradated enclosure. Ultimately, this work seems to reframe the dialogue of sustainable practice away from a focus on purely relying on technical performance and to argue for a reconsideration of our assumed notions of comfort, and one that perhaps coincides with relearning to live with a certain degree of discomfort. And I would say that broader sustainable development is inextricably tied to our cultural expectations, our values, and our aspirations, arguably in magnitudes more impactful than simple performance metrics. And so in the pursuit of an ambient architecture, I think one must consider how can we desire the uncomfortable. So the first project I'm going to share is a mixed-use building located in a developing light industrial area adjacent to downtown Boise, Idaho. And it kind of speaks to these ideas of layered space and the soft monolith. So a storefront gallery and 4 residential units are all housed within a single structure, which is enveloped by a woven wire mesh facade. This treatment of the exterior speaks to the project's industrial context and aims to reinterpret the monolithic readings of the surrounding warehouses, I should say. And so the mesh's translucency and this kind of plump, playful figure aims to kind of soften the overall form and volume of the project. And then laid beyond this outer skin, window apertures, balconies, and sunrooms pocket the facade to produce shadow, depth, and varied material expressions. And so we worked really closely with the client during the initial design phases of this project to strategize the best use for this small 7,400 square foot lot. This is a standard 50-foot wide by 150-foot deep parcel that is very typical and standard in the American West, that was originally planned to accommodate single-family homes. The local codes of the specific district have a rather draconian set of parking requirements, but by incorporating the gallery and the storefront, we were able to transition this project from a strictly residential project to a mixed-use development and ameliorate and actually eliminate these parking requirements. And therefore, we were able to achieve a much greater density on this lot than is conventionally allowed for. Expansive roof terraces were then provided to generate private outdoor space for each residence in lieu of kind of your traditional front yard, and perhaps in this way offering an opportunity for a sustainable mode of medium density living and a model for redevelopment of this lot typology. And so key to this project is that each residential unit is provided with 3 different types of space: interior conditioned space, interior unconditioned space, and of course exterior space. A shifting line of insulation is used to create what we are calling sun stairs. These are weatherproof but unconditioned expanded paths of vertical circulation, so that while in the summer months there are operable panels on the 2nd and 3rd floor that allow for stack ventilation to cool the space, and in the winter months, passive solar heat gains are used to warm the space. These spaces are by no means intended to be entirely comfortable spaces, and I would argue that they don't need to be. These are transitory zones, typically occupied for very short periods of time, and so they might be a little bit too hot or a little bit too cold, and that's not necessarily an important consideration for the day-to-day use of an occupant. But by choosing not to heat or cool these multi-story transitional spaces, the energy budget of each residence is significantly reduced, and at the same time, residents are asked to kind of take a more participatory approach to the regulation of their own thermal environment. So the act of private living is no longer confined to a hermetically sealed box, but rather there are brief moments within the home that require a confrontation with the broader reality of our collective climate. And so alongside the planning logics that are intrinsic to the climate strategy of this project, this idea of layering is further explored by the aesthetics of the envelope. And the layering that is achieved thermally in plan is in turn produced through the visual play of the wire mesh facade. This facade performs in a few ways, so mitigating solar heat gains along the southern facade, providing privacy to the residential balconies, situating the project into its industrial context. But also it eliminates the need for any additional handrails or guardrails throughout the entire structure. And so this project is actually finishing up permitting in the moment, and we're hoping to start construction later this year. So this next project is for a private house and studio in Shapira, an inner city neighborhood in Tel Aviv. And so the project site is a small, very narrow plot of 65 feet in depth and only 24 feet in width. And the client, who was a young couple, however, wanted to build a home for themselves to live in, as well as a separate dwelling in which they could work or alternatively rent out if they needed additional income. So not so uncommon to an ADU scenario in the US. So the planning of this project really aimed to achieve an amplified sense of depth and the most expansive feeling of the site possible, while accommodating a program that might otherwise overwhelm the site. To achieve this, various sizes of gardens and courtyards are planned across the plot, and at the ground level, courtyards become extensions of the defined interior, while the gardens are intended to perform as deep sceneries or backdrops. This vegetation surrounding the structure is then reflected in a processional sequence of glazing with the aim of blurring the distinction between interior and exterior space. And in doing so, seeking an ambiguity in the boundary of inhabited space so as to allow the small site to feel as if it has been extended beyond its limits. in order to provide for the desired openness and translucency that would allow us to expand the house outward into the site, we employed a double glass facade that provides buoyancy ventilation throughout all levels of the structure. This exaggerated air gap spans the full height of the perimeter of the house, expanding at the ground level to provide semi-conditioned entry halls in both the house and studio, and that exists somewhere between interior and exterior space, while contracting at the upper levels to maximize floor area. Tel Aviv, as you might imagine, experiences particularly hot summer months, and this air gap allows the heat gains that are typically the product of a glazed residential facade system to naturally exhaust upwards in this cavity and vent out the top of the structure before they would otherwise enter the conditioned core of the envelope. The peeling and layering of the facade that enables the house to expel this unwanted heat simultaneously produces distorted reflections of both interior inhabitation and surrounding vegetation that at once creates a sense of veiled privacy in this rather kind of dense urban setting, and at the same time brings the garden into the home and the home into the garden. So this project is again working through these ideas of layering and zoning to address both the climatic needs of the project, but also the aesthetic and programmatic ones. So this next project is again in Boise, Idaho, and it addresses these same themes of layered space and the soft monolith. The project was proposed to be decidedly inward-looking, drawing on courtyard housing and matte building typologies, with a translucent corrugated polycarbonate facade that wraps around the entire periphery of the structure and its courtyards, providing privacy while allowing the permeation of daylighting to the exterior-facing gardens. The images here highlight these two desired conditions. On the left, we can see the building mass pocketed by interior courtyards and sunrooms, while on the right, a translucent wrapper that varies in color and transparency in relation to these spaces within. So this project consists of 3 residential units situated between a business park, a traditional northwestern suburb, facing a parking lot, and a four-lane highway. So needless to say, this is not the most desirable location for residential living, and therefore necessitated an approach that could mediate these challenging neighbors to create a viable domestic setting. At the same time, the translucency of the enclosure blurs the articulation of the boundary of the construction, in a way borrowing landscape beyond the enclosure to allow for a greater sense of depth. So kind of again going back to themes that were present in the previous project. So in the site plan here, you can start to see that the idea was to design the 3 units as a single building. A standard module was employed for bedrooms, bathroom, kitchens, so as to achieve a certain economy of means. However, the elements are composed in a way that makes each unit unique and further enhances the ambition of creating the reading of a singular structure. Instead of deploying a repeating unit that achieves visual variation through a rotating veneer of indiscriminate materials, here the composition of the building's facade is produced through the underlying spatial and organizational principles of the project. So this composition is mediated through the singular surface of the polycarbonate facade as muted, subtle transitions of color and shadow. So here in the floor plan, you may just be able to see the interior organization of these 3 units. The building is configured so that each space has access to an exterior courtyard. And in addition to the interior conditioned space, each unit is also provided with an unconditioned sunroom that can accommodate an entry foyer, storage, a greenhouse, really however the resident chooses to use this space. And so the idea here is to provide additional square footage while not increasing the energy budget. And so, as I was just mentioning, I'm going to skip this part because it's not really that important. I will just kind of mention, though, that while I'm not necessarily opposed, and I'm not opposed to incorporating discrete applied technologies in the service of enhanced environmental performance, such is the case with this project, where the client was heavily invested in using PVs, solar hot water, grey water recycling, etc. So while I'm not opposed to these systems, using these systems and advocating for these systems, as architects I feel our agency goes beyond simply prescribing additive systems, but rather thinking fundamentally about how space is composed and used in relationship to this energy expenditure. And so kind of transitioning into the next segment of projects, in parallel with these kind of more traditional, I would say, building projects, I'm also approaching the idea of ambient architecture through research and installations that investigate the notion of performative material aesthetics. And so this proposal you see here is an installation, is a proposal for an installation on Toshima Island in the Setouchi Sea of Japan. Across the islands of the Setouchi Sea, two types of vernacular construction are commonplace: traditional wood frame houses and steel industrial warehouses. Both of these structures that were both once home to local fishers and farmers and are now used for a contemporary art triennale are typically uninsulated and provide little respite from the outside heat and humidity experienced during the extreme conditions of the summer months on the islands. So this project proposed to retrofit these structures in order to produce a new spatial and climatic interior while maintaining the history and heritage of these existing island structures. Sorry, just one second. There's ice in the water. Give me one sec. Okay. Noted. So this installation suspends sleeves of radiant barrier foil on top of welded wire mesh in the upper portion of these existing structures. Radiant barrier chips, or radiant barrier sheathing, RBS, are both common material components used in generic roof cavity construction to reflect incoming solar radiation and prevent heat gains in the spaces below. So this project uses this thermal principle while exposing this material to the viewer in the form of custom foil leaves that coalesce to form a kind of shimmering valerium. So the surface filters light through the space, creating distorted reflections of the interior below while simultaneously producing a cooler environment. So the intention being here to propose a system where visual phenomena and building performance are unified. So the muted reflections of the occupants below and the changing quality of light from the structure skylights over the course of days and seasons really speak to this kind of ephemeral nature of the proposal. So the aesthetic expression of the installation transforms over time in response to its use and to the island's ambient conditions. I'm going to try this once more time. Okay. So the next project I'm going to show today is a prototype for an evaporative cooling roof, which was explored and analyzed as case studies for a logistics center in California and a large urban park in Abu Dhabi, both of which you can see here. Actually, just the last one you can see here. And it was also realized as a one-to-one mock-up that was installed as a pavilion at the Princeton University School of Architecture, which, as you can see here on the left, this installation really aimed to challenge the notions of how we understand enclosure as it relates to the thermal performance of a building. The pavilion itself is entirely unenclosed, consisting only of an elevated roof, whereby the air underneath the roof is the same temperature as that of the surrounding courtyard. Yet it is possible here, through the principle of radiant heat exchange between the human body and a cool surface, to achieve thermal cooling. And so here, I'm proposing a building without walls model for producing thermal comfort and the generation of an interior climate. The assembly of the prototype itself is very simple. A 10 millimeter layer of water sits on top of a transparent ETFE membrane, which is tensioned between a steel frame. This is then covered by aluminum shading fins, which prevent direct solar heat gain on the water surface. The prevailing ambient conditions of air temperature, relative humidity, and the movement of air across the thin layer of water then cause the water to evaporate from the roof surface. The underneath of the roof in turn approaches wet bulb temperature, which is the lowest air temperature possible to be achieved through the evaporation of water alone. And so these thermal images that you see on the bottom left here were taken on a typical spring day in early May. And so you can see that perhaps you can see, yeah, you can see, that the underneath temperature, the temperature of the underneath surface of the evaporative roof was recorded at 18.4 degrees Celsius, while the brick facade of the adjacent School of Architecture building reached 28.5 degrees Celsius. And so kind of to put this into comparative terms without having to translate this into Fahrenheit, the amount of energy removed from the surface of the roof of the summer pavilion would equate to installing 47 window air conditioning units in the facade of the School of Architecture building. And this is in order to achieve the same amount of cooling that is generated in the prototype. And so in the case study for the Logistics Center in California, however, which is an environment much more conducive to evaporative cooling than rather muggy New Jersey, a typical roof in California can reach somewhere in the range of 60 to 100 degrees Celsius. So on any given day, with kind of nominal weather conditions, so not extremely hot and not cool, the resulting energy potentially removed by an evaporative cooling roof would average around 355 watts per square meter. And this is without the use of major mechanical systems. And so to give you a sense, again, of the magnitude of this, heat gain from the air is around 10 to 50 watts per square meter, while heat gain from the sun averages around 100 watts per square meter. And so the prototype itself is removing 350 watts per square meter. And so it really kind of in parallel with this kind of potential for interior cooling, there's also a significant potential for the mitigation of the albedo effect because of this removal of heat from the roof surface. Meanwhile, there's also another result of this exercise in the speculative building performance, and that's the aesthetic and spatial effect of the prototype. The transparency of the water layer and ETFE membrane allow diffuse daylighting of the space below, and the transmission properties of water mean that while light in the visible spectrum can pass through it, infrared and ultraviolet light are entirely absorbed. Not entirely, but very much in an identical fashion to that of low E glass. And so the idea is that the space below is really imbued with the subtle caustics of evaporating water, and this kind of performative climate device takes on its own spatial and aesthetic language. One last note that I kind of want to mention about this project, and one that has become kind of really intrinsic to and important to my research methodology, is an awareness of the waste that is typically associated with temporary architecture. This project has far outlived its initial research purpose, and now, almost 5 years after its initial construction, I'm told is a favorite student lunch spot for the architecture students at Princeton. So it's kind of taken on a life of its own, and one that kind of provides ongoing value to the school and its community. And I'll kind of touch on this in a little bit again. Okay, so I'm gonna close today on the research that I've been conducting here at Knowlton as part of my LeFevre fellowship. Foundational to this design research is an awareness of the systemic inequalities latent in the built environment. Underlying this work is an interest in the provision of public comfort, but with an understanding of the increasing inutility and inaccessibility of communal space within the city. This combination of historic planning prejudice and the ongoing climate crisis have compounded the scarcity of usable public space, particularly in marginalized communities. Los Angeles County, where my practice has previously been based, for example, which, perhaps until recent months was known for having a rather idealized climate. Los Angeles County by 2053, I believe, will actually experience triple the number of extreme heat days. And these extreme heat days disproportionately affect low-income and minority neighborhoods. So studies conducted out of UC San Diego show that these communities experience land surface temperatures of 7 degrees Fahrenheit greater than wealthier, predominantly white neighborhoods in Southern California. And this discrepancy holds across the United States, and even when you control for income. And so this project is specifically investigating the use of a relatively new passive radiative cooling film and its ability to modify outdoor thermal comfort, and in conjunction with the architectural implications of this application. And so the project seeks to forefront an awareness of these systemic urban issues while actively engaging in opportunities for architecture to meaningfully address this reality as we experience an increasing number of extreme heat events. And so the film that I'm working with, that is manufactured by 3M, is a dual mode film, which means on the one hand it's highly reflective and thus avoids direct solar heat gains, but perhaps more interestingly emits infrared heat through the Earth's atmosphere to the cold of space. And through this emission reaches below ambient temperatures even when in direct sunlight. And so, conventional roof surfaces are typically around 6 degrees Fahrenheit hotter than ambient air, while passive radiative cooling film applied surfaces average just over 1 degree cooler than ambient air. And so the film has typically been deployed as an additive system, which is then applied to buildings with existing HVAC systems in order to improve their efficiency. What I've been working on, however, is developing a roof assembly that utilizes the film to act as a singular independent system that improves outdoor thermal comfort by providing passive radiant cooling to an occupant below. So in a sense, acting very similarly to the previous evaporative cooling project. Architecturally, however, this is to be manifested as an impossibly thin structure, a sheet of paper thrown into the wind, so to speak, which allows for the maximum amount of cooling generated in the film to be transferred to the underneath of the canopy. And I think I touched on this earlier, but thermal comfort is the product of various factors, not simply air temperature or air movement, but also mean radiant temperature. The surfaces around us all have a certain temperature associated with them, and they are presently affecting how comfortable we feel in the space, not by changing the temperature of the air, but by heat exchange with our bodies through radiant heat exchange. And so our team that I've been working with, several colleagues of mine that I have an ongoing collaboration with, we predict that by utilizing the passive radiative cooling film on the roof surface of an outdoor structure, this will result in the reduction of mean radiant temperatures by 2 to 4 degrees Fahrenheit when compared to a control roof surface. And so, on the other hand, the other interest in this work is the ability to not only provide improved thermal comfort for the individual, but also when deployed as an urban infrastructure, a roof surface that reaches below ambient temperatures offers significant potential to address comfort at the scale of the city by reducing the albedo effect and by lessening the impact of urban heat islands, which again disproportionately affect marginalized communities. So I'm currently working towards the construction of a full-scale prototype that's to be installed here on campus in front of Bricker Hall this summer. And following this installation period, the intention is to rehome this pavilion to OSU Extension at Waterman Farm for their long-term use by their Master Gardener program, and also shared with the James Comprehensive Cancer Center's Garden of Hope program. And so this really goes back to, as I noted in the previous project, this kind of foundational ambition in my installation work which is to find an ongoing utility and life beyond the research itself, so as to reduce waste and profit as much as we can from the resource that we do use in our work. Interesting. There should be one more slide. Here we go. Okay. Didn't want to go. Anyway, I am going to conclude there. Hopefully, I've kind of provided a little bit of insight into the work that I'm pursuing, both in my kind of research here at Knowlton as the LeFevre Fellow and in my professional practice, and also the kind of general framework in which this work is operating. I do have a few quick thank yous to make. Firstly, to Matt Daniels and his team at Buckeye Metalworks for their very generous support of the exhibition and their fabrication expertise. The Ohio State Sustainability Institute, which has been incredibly supportive of my work. Katie Picellio, my fantastic GA Alison Summers, who probably never wants to sew anything again in her life. And to my wonderful students, Anna, Christian, Dia, Gabrielle, Carly, Lizette, Nolan, and Tim. I've had a fantastic time working with you all, so thank you. And with that, I would like to invite you all to join me in the Band Gallery for a Q&A and opening reception of the exhibition.